first example wants us to expand the natural log of 5x to the 7th over y. Okay, so let's remember the things that we learned. The main thing that's happening here is we have a division problem. So I've got natural log of 5x to the 7th minus the natural log of y. But now I've got things that are being multiplied. So I know that when they're being multiplied, I split them up and I add them. So this is the natural log of 5 plus the natural log of x to the 7th minus the natural log of y. And now I just have one more thing to do, and that is this exponent right here, this 7. So this is natural log of 5 plus the 7 gets bumped out front, 7 natural log x minus natural log y. So why didn't I bump that 7 up at this point in the problem? Well, it's because the 7 only applies to this x. It doesn't apply to the 5. Now it would if I had parentheses right there, then it would look different. But just know that that x only applies to that 7. Okay, so here are some for you to try. So if you would try those, you can stop your video now. All right, so let's see what we've got. We have another multiplication problem here. So this is log base 6, 3 times x to the 4th. This is log, I just totally rewrote it. That was dumb. Like, it's right there. I don't know why I wrote it again. Okay, log base 6, we've got 3. It's being multiplied, so I'm going to add log base 6, x to the 4th. And now our last thing is to take this exponent and put it out in front. So log base 6 of 3 plus 4 log base 6 of x. Now this one's a little trickier. We've got a division problem, so I'm going to do natural log, and it doesn't matter if it's a log or a natural log. Natural log of 5 minus the natural log of 12x. Okay, well 12x, the natural log of 12x is one entity here. So when I separate these, I'm going to keep them in parentheses. Natural log of 12 plus natural log of x. And now this is going to distribute. So we've got natural log of 5 minus the natural log of 12 minus the natural log of x. Okay, I hope that that was easy for you. Okay, so condensing is the opposite of expanding. So now we're going to take each one of these terms and look to see if there's anything we can do with them first. Okay, log 9, there's nothing. There is something I can do here, and there's nothing I can do with this one. So this one, I got log 9. This is plus log 2 to the 3rd. This one is out front. Now I'm going to bump it back over to here when I'm condensing. Minus log 3. So what I've got here is log of 9 times 2 to the 3rd, right, because it's being added. So I put them together and multiply. Divided by, we've got the minus here, 3. So this is log of 9 times 8 over 3, which is log 24. Okay, so here's a couple I want you to try. So go ahead and pause your video now. All right, so we've got a minus here, so that means that we're dividing. So this is log x divided by 9. Over here, we have that little step that we can take at the beginning. This 3 gets put here. So this is the natural log of 3 cubed minus the natural log of 12. Okay, they're being added, so I'm going to multiply. So this is 4 times 3 cubed, and it's subtraction, so I'm dividing, divided by 12. And this becomes the natural log of 9. I feel like I'm going really fast, but I guess you can slow this down if you want to. Okay, so here's a question, and this is a problem we've had from the beginning. How do we solve a log that's not a base 10 log? Okay, how do we solve log base 2, 6 without a graphing calculator? Okay, we have something called the change of base formula. And this, it looks really complicated. I promise this is not a hard thing to do. Okay, this is the very basic definition, but what we really use is this one. So if I have log base C of A, it's log of A over log of C. And we can use it for natural log too. Natural log of A over natural log of C. So the way that I remember it is the C right here is the base, and the base needs to go in the basement. So that's how you remember which one goes on the bottom. Okay, so let me just do some examples. This is really, really easy. So this I've got log 8 over log 3. That's it. And then you put it in your calculator. And you get something so cool, it'll blow your mind. Not really. 1.8928. So that's the answer to that one. Then you could also actually use natural log of 8 over the natural log of 3, and you will get the same answer. Okay, that I think, oh, I wanted you to try these. Yeah, go ahead and try these. Pause your video now, or whenever you feel like it. Okay, sorry, I can't cut that last part out. Okay, we've got log 8 over log 5, and we put that in our calculator, and we get 1.292. And over here we have log 14 over log 8, and we end up with 1.269. Again, what are these numbers? What do they even do? So remember, 5 to the 1.292 power is 8. That's what this is telling us. What exponent goes here that gives me 8? So here I have 8 to the 1.269 power gives me 14, or roughly 14. Okay, that is what I have for you. Let me know if you have any questions.